We are looking at algebra. This is 8.5, and we're looking at solving quadratics by graphing and the square roots, and by solving quadratic when they are square roots. So we're going to first talk about when we have a parabola and a quadratic, we talk about roots. And roots are, these are the points at which the parabola crosses the x-axis. So at times the parabola will cross the x-axis. I'm referring down here. At times, sometimes they cross twice, sometimes they only touch once, and sometimes they don't at all. So these are also called, so the points at which the parabola crosses the x-axis, also called the zeros, the solutions, the roots. So you hear it called roots, that's what it means. And sometimes they'll refer to the x-intercepts. Okay, so a lot of times they'll say what the solutions are, what are the zeros. Well, what they're talking about is what the zeros are, is when they cross. So here's an example of two solutions. Okay, so here's the parabola. Here's an example of two solutions. They have two because they're crossing the x-axis twice. Here's an example of a one solution. If they touch the x-axis in one part, that's a one solution. So if they only touch it, the vertex is the zero. So when y is 0. So it can be here, it can be here. It doesn't matter where it is. If it only touches the x-axis once, that's a one solution. And then there's going to be times to where it won't touch the x-axis at all. So this is called a no solution. Okay, so we have two solutions, one solution, or no solution. Now we're going to talk about, you're going to hear this, it's called the discriminant. The discriminant, and we use to determine the numbers of solutions. So we can use this formula to determine the number of solutions that happen with that certain quadratic. Okay, now if D equals, if D is greater than 0, which means the discriminant. So this is going to be, maybe if you want to say D equals B squared minus 4AC. So this is why it was so important to know the A, B, and C term. So I'll come back, let's come back to this part. Let's go over here. So x squared plus 5x plus 4. Okay, now, so we want to do the B squared. This is your A, this is your B, this is your C, remember? So you're going to do B squared. So you're going to say 5 squared minus 4, A is 1, C is 4. So this is going to be 25 minus 4 times 1 times 4 is 16. 25 minus 6, I don't know why I did that. 25 minus 16 is 9. And so what's going to happen here, if the discriminant is greater than 0, there are going to be two solutions. So this quadratic is going to be two solutions. Now, right now, everything that you guys do and practice, use your notes. This is not something you have to memorize. So use all of these notes when we do these. Okay. Now, this one, remember your B squared minus 4AC. So your B squared is negative 3. Negative 3 squared minus 4 times your A term, which is 1, times your C term, which is 10. Okay. Now, 3 squared is 9. So that's going to be 9 minus 40, which is going to be a negative 30, not 36, 31. I don't know why I did that. 31. Now, if the D is less than 0, so the D is, this is in the negatives, there's going to be no solutions. Okay, B squared, negative 12 squared, minus 4 times 9. Negative 12 squared is 144. Then negative 4 times 9. Okay, so 4 times 9 equals 144. Now that's a negative, so it's 144 minus 144. That's 0. So if it equals 0, there's going to be one solution. So this is going to be a one solution. This is going to be a no solution. So we can use the discriminant to determine the solutions, like just the number of solutions or the number of times it crosses the x-axis. All right, so we're going to finding the solution of the quadratic function given the graph. Now the solutions means where it's crossing the x-axis. So when it says the solutions, where it crosses the x-axis. Well, in this case, it's at 2. So you can write it a couple ways. You can say an ordered pair. You can say 2, 0 is a solution and 6, 0 is a solution. Or you can write it as a set. You can say x equals, now this is representing set notation, 2 and 6, not that 2, 6 is the ordered pair. It's not saying 2.6 is the order, or 2, 6 is the ordered pair. What this is saying is a set notation that 2 and 6 are both solutions to that. This one now, the only solution we have, you can write it as an ordered pair of 3, 0, or you could write it as the set includes 3. So this is where you're using your braces, and this is a set notation. Okay, so the solutions would be 2 and 6. The solution to this one would just be 3. If it's a no solution, you would do this. Whoops. You would do like empty set. Okay, and that's what that 0 and the line like that would be. That would be classified as empty set. That would be a no solution if there was one. Okay. All right. Now, this is one that we're going to practice with graphing. Now, so we can do this with graphing. So remember, we can do the negative a or negative b over 2a. It's not in vertex form, which is darn, because I like it when vertex form. And we can actually do all the things that we've done before. So finding solutions of quadratic by graphing the equation. So we need to find the axis of symmetry, the x value and the y value. So opposite of b, opposite of 2 over 2 times 1, which would be negative 2 times 2, negative 1. So it's going to be, I'm going to make a little table here. So negative 1, now I got to plug in negative 1 to solve for y. Oops, that's a minus 3. It's 1 minus 2 minus 3, negative 1, 1 minus 2 is negative 1, minus 3, that's going to be a negative 4. So our vertex is negative 1, negative 4. These aren't labeled at all. So 1, 2, 3, 4. Negative 1, negative 4. Okay, so let's just do 2 points. Let's do negative 2 and 0. 0 is nice. 0 is always a good one to test because that's going to be 0, negative 3. Actually, 0, negative 3, 0, 1, 2, negative 3. That means this one's going to be negative 3. Negative 2, negative 3. Now, so, oh wait, I'm doing this way wrong. Actually, what we need to do is well, you don't know how to do that yet. Okay, so just continue sketching up. So when y is 0. When y is 0, so it's going to be like that. So it's going to be 1, 2, negative 3, and 1. So the two solutions here are going to be negative 3 and 1. Okay, so two solutions that are going to be negative 3 and 1. Now, in reality, you guys, you're going to have graphing calculators. You're going to have the computers graphing. So I wouldn't worry about this too much. Okay, now, let's do, okay, so the negative, let's find this one. The opposite of b over 2a. So the opposite of b, the opposite of negative 4 over 2 times 1. Opposite of negative 4 is 4 over 2, so that's 2. Put in 2, so 2 squared minus 4 times 2 plus 5. I'm putting it back into our equation. 4 minus 8 plus 5. That's a negative 4 plus 5. That's positive 1. So 2, 1 is the vertex. Look at this. So we have 1, 2, 2, 1 is the vertex. Okay. 2, 1 is the vertex. So that means if we put in, okay, 2, 1, let's put in 0 for x. I like using 0 because it's easy to solve. You put 0, 0, and that's 5. Then, since that's 2 down, if we put in 4, that should be 5 also. What I did was 2 below, 2 above. So 0, 5, 5, and then 4, 5. These lines are hard to tell. Okay, look what happens. This does not cross the x-axis at all. This is a no solution. Meaning that there's no solution to this. It does not cross the x-axis. Okay, I think I'm going to stop there and come back and do this one second.